Here we have a probability distribution that tells us about the number of games played in a World Series of baseball. In the World Series, the first team to win 4 games wins the World Series. Thus, the series can last 4, 5, or 6 or 7 games. In this table, we're told that the probability the series lasts 4 games is 0.19, probability the series lasts 5 games is 0.21, and so on and so forth. In Part A, we're asked to find the probability that the series lasts 6 games. Well, probability that x is at least 6 would mean x is greater than or equal to 6. And so to find that, we add together the probability that x equals 6 times the probability that x equals 7, which is 0.22 plus 0.38, giving the probability of at least 6 games being 0.60. In Part B, we're asked to find the probability, we're asked to find the mean value of the random variable x. Mu sub x can be found by taking the summation of each value times its probability. In this case, that would mean 4 times its probability 0.19, plus 5 times its probability 0.21, plus 6 times its probability 0.22, plus 7 times the probability of 7 games, 0.38. This will give us 5.79. To interpret this value, the mean is also called the expected value of x. Thus, we can say that when the World Series is played, we would expect the series to last 5.79 games. Of course, you can't play 79 hundredths of a game, so this means we would expect about 5 or 6, probably closer to 6 games, since 5.79 is closer to 6. Part C then asks us to find the standard deviation of the random variable x. This will give us a sense for how much variability there is from series to series in the number of games. Sigma sub x is the notation for the standard deviation of a random variable. The formula for the standard deviation is the summation of each value minus the mean squared times the probability. A variation of this formula makes the calculations a little bit easier to handle, and that is we take each value squared times the probability, and then from that summation we subtract the square of the mean. So we do this summation first, subtract the square of the mean, and then take the square root. To use this formula, I take each value, 4 squared, 4 is the first value, I square it, and multiply by its probability. I add to that the second value, 5 squared, times its probability, and so on and so forth. 6 squared times its probability 0.22, 7 squared times its probability 0.38, and then finally from that summation I'll subtract the mean, 5.79, squared. Following the order of operations, exponents, multiplication, and then the addition and subtraction, underneath the square root we get 1.3059, making the standard deviation approximately 1.14. This represents the number of games that we expect the series to vary by, about 1 game. So, on average, every time a series is played, we expect those series to last 5 or 6 games, and we know that there's some variation in that of about 1 game.